So you're driving down the highway, and an 18-wheel tractor-trailer is coming up fast behind. You've got to change lanes. You look in the mirror. Is there enough space? And you notice the words on the mirror. Objects in the mirror are closer than they appear. No kidding! Well, it's the same with the Milky Way galaxy. There's another galaxy headed this way, and like the tractor-trailer, it's closer than it looks. The Andromeda Galaxy, or M31, as it was labeled originally by Charles Messier in his catalog of 110 fuzzy objects in 1774, is now officially named NGC 122, that's New Galactic Catalog 122. A spiral galaxy larger than the Milky Way, the Andromeda Galaxy is so big and so close that you can see it without a telescope. In fact, it appears with the unaided eye half as wide as the Moon. It's estimated that the Andromeda Galaxy contains 1 trillion stars, compared with the Milky Way's estimated 300 to 400 billion measly stars. To see the Andromeda Galaxy, you must allow your eyes to become dark adapted. This might take about 10 minutes while your pupils dilate to take in as much light as possible. M31 is best seen from late summer through winter, when the great square of Pegasus the Winged Horse is overhead. Draw a line across the great square diagonally upwards from the lower corner star, then go a little further beyond the square. There it is! But you still won't be able to see how big it is unless you peek at it from the corners of your eyes. If you stare straight at it, the galaxy will tend to fade away. You must use your peripheral vision to see how big the Andromeda Galaxy appears. Peripheral vision, or averted vision, allows you to see light more sensitively at night, but without color. Sailors have used averted vision for centuries to see faint lights out on the ocean or on land. Aristotle used averted vision to observe star cluster M41 in Canis Major, as he described in his book Meteorologica. In a telescopic photograph, the Andromeda Galaxy appears 6 times wider than the Moon, because with the unaided eye, we can only see the bright center of the galaxy. A telescopic photograph shows how massive M31's spiral arms really are. And this beast of a galaxy is headed our way. We are looking at a future massive collision of galaxies of, well, galactic proportions. When that happens, humanity may need to relocate to another galaxy to inhabit. Perhaps we'll go to the Pinwheel Galaxy in the asterism of the Big Dipper. How do we know the Andromeda Galaxy is moving towards us? With a tool called a spectroscope. After the camera, the spectroscope is the most important attachment to a telescope. Oh, except for the human eye. Our eyes only see light. You don't have this big horse in your eye. You only have the light being reflected by the horse in your eyes. The same with space. We only see the light coming from there. So, if we are going to understand space, we need to understand light. And that was not an easy task for astronomers of the 19th century. The invention of the spectroscope was a big breakthrough in understanding light coming to Earth from space. With a spectroscope, astronomers can tell which direction objects in space are moving, as well as which elements are making the light. When you hear an ambulance approaching, you hear the siren getting louder and higher, and when it passes you and goes away, you hear the siren's sound get weaker and lower. The change in pitch frequency depends entirely on the motion of the source. This is called the Doppler effect, after the Austrian physicist and mathematician Christian Johann Doppler, who first explained the effect in 1842. The ambulance siren is not changing its volume. The sound waves are being compressed as it is approaching and stretched as the ambulance recedes. The spectroscope shows that light waves show the same Doppler effect as sound waves. They are compressed as the star or galaxy is approaching us and appear stretched when it is receding. Therefore, the light from an approaching galaxy will appear slightly bluer, the blue shift, a slight increase in frequency, and the light from a receding galaxy will appear slightly redder than normal, or red shift, a slight decrease in the light's frequency. In 1929, Edwin Hubble, after whom the Hubble spacecraft is named, published his spectroscopic study of 46 galaxies, the light from all but one of which was redshifted, moving away. Hubble's study provided the first evidence that the universe was expanding. The farther away a galaxy was from the Milky Way, the faster it was moving away. This was also the first evidence that the universe began with a Big Bang. The one galaxy whose light was blue-shifted moving towards the Milky Way, was M31, the Andromeda Galaxy, the closest galaxy. 250,000 miles per hour seems a pretty high speed at which to have a collision. That's the speed spectroscopic measurements of the blue shift of Andromeda indicate. It's going to be a big mess when it happens. But when is it going to happen? To determine when the two galaxies will collide, we need to determine the distance between them. And for that, we need, boom, supernovas. Type 1a supernovas are what are called standard candles. Just as we know how bright a candle shines, we know how bright a Type 1a supernova shines, its absolute magnitude. A Type 1a supernova appears when a white dwarf collapses under the pressure of all the gas it has been gravitationally slurping from a companion star. Looking at the Andromeda Galaxy and measuring the apparent brightness of a supernova in the galaxy, it is possible to calculate its distance away from us. Because the intensity of light dims inversely with the square of its distance away, which is called the inverse square law, by comparing the apparent brightness of a supernova in the Andromeda Galaxy with its absolute brightness, well, we get an approximate distance of 2.5 million light-years. Since 1 light-year is approximately 6 trillion miles, and the Andromeda Galaxy is 2.5 million light-years away, even though it is approaching at the speed of about 250,000 miles, we have about 4 billion years before the big collision. So you can wait until after lunch, maybe dinner, to start packing. As an aside, if we see the Andromeda Galaxy as it was 2.5 million years ago, and it has been moving toward the Milky Way all this time, how big in the sky would it appear now? Quite as big as that tractor-trailer in your rearview mirror. But do we really have 4 billion years before the galaxies crash? There are several other factors to consider. The minor galaxies that are gravitationally linked to both the Milky Way and the Andromeda Galaxy will be swallowed up by their host galaxies. Considering the lopsided mass distribution that will result, the galactic collision of the Milky Way and Andromeda will be affected. Some scientists are saying it won't be a direct hit, but more of a sideswipe. And then there's the galactic halos of each galaxy. Here's what Project Omega has found out about the halo of stars and gas surrounding the Andromeda Galaxy. Using the Hubble Space Telescope, researchers were able to observe how the light from bright distant quasars were being absorbed by the mostly invisible gas around the Andromeda Galaxy. Look at the results. Notice M31 in the center. If the same is true of the Milky Way, and there's no reason to think it would be different, then the halos of the two galaxies are touching now. The collision has already begun. There is also a question about what effect the dark matter clouds around each galaxy might have on an impending collision, or are having now. But enough of speculation. In 4 billion years, the Sun will have increased brightness on its way to becoming a red giant star. And humans will have already found another galaxy to inhabit. Happy traveling, dear humans!